Welcome. Today we'll be talking about nanotechnology. Over the course of history, we have undergone some pretty big changes in medical field advancements. But what if, instead of being in 2025, we were in the 1800s? This is nowadays us. Let's go back in time. The 1800s were perfect. You had so many great things to look forward to, such as smallpox, with roughly a 40% mortality rate. Surgery, which was conducted while being wide awake. And don't forget about that lovely cough, tuberculosis, being 25% of all deaths in Europe and North America. But play your cards right, and you might have made it just in time for some awesome medical advancements, like anesthesia. So, no more wide awake surgeries. Vaccines to prevent any future germs getting to you and causing mayhem. And as for that coughing, you're gonna have to wait till the 1900s to get your tuberculosis cured. What about today? What are the big problem causers? What is being done about them? Are there any advancements today that are just as important as the ones in the 1800s? Well, in short, yes, of course. With one of the biggest achievements being, yep, you guessed it, nanotechnology. It sounds very high-tech, but what is it? If we do a simple Google search, we are left with this. The branch of technology that deals with dimensions and tolerances of less than 100 nanometers, especially the manipulation of individual atoms and molecules. But what does that mean? Well, nanotechnology is the combination of science, engineering, and technology conducted at the nanoscale. It is the exploitation of the unique properties of materials at the nanoscale, being able to give these tiny advancements jobs of sorts by harnessing their capabilities. Creating nanomaterials is made possible by the manipulation of structures at the atomic level. At the nanoscale, nanomaterials possess special optical, electrical, and magnetic properties which allow their use in a range of areas including electronics and healthcare. The concepts and ideas of nanotechnology started in 1959 when physicist Richard Feynman gave the talk "There's Plenty of Room at the Bottom" at the California Institute of Technology. He goes in to describe how scientists can manipulate individual atoms and molecules. It wasn't until the scanning tunneling microscope was developed in 1981, which allowed scientists to see individual atoms, that nanotechnology could begin. Imagine being the guy to come up with this thing. But for right now, let's focus on the medical side of nanotechnology. This is called nanomedicine. But just like our previous question of what is nanotechnology, what is nanomedicine? Is it tiny robots that go into our bodies and fix us? Lab-controlled matter that has its own mission? Or is it more like Iron Man suiting up? As cool as that may be, it's not that one. Before we can answer this, let's ask ourselves, what is it needed for? What is the problem that needs this medical advancement on such a small scale? One of the biggest uses of nanomedicine is its ability to have targeted drug delivery. This means nanoparticles are designed to deliver drugs directly to diseased cells or tissues. Having this direct contact between drug and cell means there would be less side effects from the medicine received. Think about the biggest problem in the medical world. Did you think cancer? I did, as this is the second leading cause of death worldwide, with heart disease being number one. Antibodies which bind to receptors commonly found on cancer cells can be coated onto nanoparticles, which can be seen on MRI and CT scans. We wouldn't just be able to see that there is cancer, but also types and stages. Normally, someone with cancer would receive chemotherapy and the cancer cells would be killed off. Although there are several issues with chemotherapy, as it kills the cancer cells and the healthy cells. Nanoparticles are hoped to be more specifically targeting just the cancer cells. leaving alone the healthy ones. Enough of all the big talk, and let's break it down in a much simpler manner. Nanoparticles consist of micelles, which spontaneously aggregate and self-assemble, liposomes. Their surface characteristics can be modified with polymers, antibodies, and/or proteins. Dendrimers. These are used to modify the entire structure or the chemical and physical properties. Carbon nanotubes, which allows us to achieve considerably high loading capacities as drug carriers. Metallic nanoparticles. These consist of active targeting, image contrast agents, optical biosensors, and drug delivery vehicles. Quantum dots. These are employed in the field of medical imaging. Did you get all of that? It's a lot, I know. But it's some pretty cool stuff. A good example of the use of nanotechnology would be the COVID-19 mRNA vaccine. Lipid nanoparticles are used in this vaccine to counter the two main challenges when it comes to delivering mRNA. The first challenge being that there are many RNA-degrading enzymes in the body that could destroy the mRNA. To counter this, the vaccine is surrounded by lipid nanoparticles to act as a barrier to protect the mRNA. Additionally, because our cells are surrounded by negatively charged membranes, it would be impossible to put a negatively charged mRNA across this barrier. With the help of nanoparticles, the mRNA is facilitated into the targeted cells. With nanomedicine making large strides and succeeding in many fields, we could be looking at medicine in a whole different way than we do now within the following years. In this real-life example, published on the National Library of Medicine, we can see prostate cancer cells have taken up fluorescently labeled nanoparticles. As targeting molecules on the nanoparticles bind to the prostate-specific membrane antigen. These designed targeted nanoparticles are capable of getting inside cancer cells and releasing lethal doses of chemo to eradicate tumors. In this example, we can see a cancer cell and a normal cell. The cancer cell is much more vibrant than the normal cell due to the amount of large nanoparticle intake. This means we can single out cancer cells amongst our healthy ones. This alone is strong evidence that nanomedicine will be greatly impacting our futures in the medical field. I'm excited to see what new innovations will come of it in the passing time. Who knows, maybe a few years down the line, you'll have some problems that nanomedicine will solve. And you can think back to this video and have somewhat a better understanding of what's actually going on. Thank you guys so much for sticking around to the end of the video. Hope you enjoyed it as much as I enjoyed making it. If you want to check out this nanotechnology stuff yourself, I'm going to put some stuff on the screen here. These are the sources I used, and it's some pretty cool stuff. You all have a good one, and I'll see you around.